Digital Track Circuit Digicode is a remote feed jointless audio frequency track circuit. Digicode is available in two configurations: DTC24 LF low frequency and DTC921 HF high frequency. The main difference between the two configurations is the frequency range in which they operate. This system includes power supply unit. The transmitter consists code generator, MSK modulator, amplifier, transmitting filter, lighting discharge, transmitting end cables, tuning unit at transmitting end, bonds on rail, tuning unit at receiving end, receiving end cables. Receiver consists receiving filter, receiving amplifier, demodulator, comparator, delay circuits, amplifier, magnetostatic relay MSR, train detector, the relay. Main features: DTC. Minimum ballast resistance equal to 2 ohm per kilometer. Train shunt resistance equal to 0.5 ohm outside the tuning zone. Train shunt resistance equal to 0.15 ohm inside the tuning zone. Power consumption equal to 50 to 140 volt A. Rail types equal to 90 pound, 52 kg, 60 kg. One transmitter can coupled with maximum 3 receivers. Remote feeding equal to 3 km. Cables for feed in and feed out. Quad cable 0.9 mm diameter copper conductor as per specification ALSTC 30 of 96. Modulation minimum shift keying. Bit pattern coding 3 types for each frequency, total 42 code bits. Transmission speed 400 bits per second. DTC24. Operating frequencies: F1 2100 Hz, F2 2500 Hz, F3 2900 Hz, F4 3300 Hz, F5 3700 Hz, F6 4100 Hz. Frequencies at gap of 400 Hz. Length of tuning zone equal to 18.6 meter to 27 meter. Length of track circuit. DTC921. Operating frequencies: F7 9500 Hz, F8 11100 Hz, F9 12700 Hz, F10 14300 Hz. Length of tuning zone equal to 6 meter. Length of track circuit. Front view of Subrack. It houses the electronic boards of 2 digicode AFTC. The rack for the electronics corresponds to Euro standards 6U into 84T, 256 into 427 mm with a maximum depth of 420 mm. The electronic boards conform to Euro standards 6U into 280 mm depth. The electronic boards are inserted into the slots from the front of the rack. AFTC Subrack for straight track circuits. DTC24 and DTC921 front view. AFTC Subrack for center feed track circuits. DTC24 front view. AFTC for point zone track circuit. DTC921 2RX and a 3RX front view. Rear view of Subrack. The rack includes 2 motherboards, one for each subsystem, for the interconnection of the various boards, the power supply and the connectors to the field equipment. The power supply to each of AFTC is located at the rear end. 2 modules into the rack, one for each subsystem. The dimensions are 3U into 4T 2T with 103 mm depth, a 110 or 230 volt socket with 50 or 60 Hz filter and an on and off switch are located. AFTC open rack cubicle mounting details. Each rack can accommodate 6 to 8 track circuits. This ensures the high availability of the whole system. The rack consists of following components: DIN channel for mounting lightning discharger, relay bracket for fixing the relay, earth bus bar, 1000 ohm 24 volt DC Q series type, bus bar with Vago terminals for 110 volt or 220 volt AC power inputs, cable duct for routing cables, set of grounding bolts, pin type 200 mm by 12, 4 numbers, set of cage nut screws for fixing AFTCs, maximum 8 numbers per card frame. TXRX module. On front panel of this module, following are provided: power on switch, gain adjustment arrangement, measuring sockets, LED indications, fuses, arrangement for fittings. This module consists transmitter card and receiver card. Transmitter card, TX card. The modulated signal from modem card is feed to driver of circuit. Without enable, the modulated signal will not pass to amplifier. The power driver consists of a push-pull type MOSFET amplifier with transformer output, whose secondary supply is used to adjust the voltage in accordance with the length of TX cable. The modulated signals are amplified, which is having narrow bandwidth. The amplifier is commanded with square wave signals whose division is very close to 50 by 50. As a result, the output voltage of the amplifier cannot increase if there is a fault. It is second order filter constructed with passive component having property of flat stop band for fail-safe requirement. The filtered signals are coupled through adaptive isolation transformer. These coupled signals are fed to TU unit via quad cable. Test points: VTX, voltage at the secondary of the power amplifier output transformer. If 10 volt fuse at 10 volt DC, VTX equal to 1.2 volt AC to 3 volt AC. If 50 volt fuse at 50 volt DC, VTX equal to 6 volt AC to 90 volt AC. Caution: the wave measured at the VTX test points is not sinusoidal but squared. Vout, voltage at the primary of the TX cable matching transformer. If 10 volt fuse at 10 volt DC, Vout 0.8 volt AC to 1.9 volt AC. If 50 volt fuse at 50 volt DC, Vout equal to 2 volt AC to 45 volt AC. 10 volt DC at 10 volt fuse equal to 9 volt to 11 volt, or 50 volt DC at 50 volt fuse equal to 45 volt or 58 volt. DC fuse rating equal to 6 ampere, 250 volt slow blow glass fuse. Red LED indication is given for this supply. Adjustment of gain: maximum gain when jumper on 1 and 2, 15 and 16. Minimum gain when jumper on 7 and 8, 9 and 10. Receiver card RX card. The input signals are coming from TU. The received signals are filtered through 4th order Butterworth filter and amplified by selective amplifier. The 4-stage band pass filter is designed with Butterworth 4th order with passive components for fail-safe requirements whose bandwidth is narrow. The property of Butterworth filter is flat pass band and flat stop band. The RX circuit is isolated at input side and output side to restrict flow of unwanted signal from external world. The weak modulated signals are amplified and feed to RT card and modem card. Test points. 24 volt DIG. On the DC voltage destined for the selective amplifier, red LED indication lit for this supply, delayed type fuse 1 ampere. VIN, voltage on the cable side winding of the receiver cable matching transformer. Caution, this voltage may be affected by disturbance coming from the field which can alter the reading. VIN, greater than 300 mV AC, which comes from TU. 24 volt LOC on the DC voltage destined for the RT card relative to the comparator circuits, the delay of 1 and 2, the 20 kHz generator, the amplifier and the branch circuit command. VRX, voltage at the input of the amplification stage of the signal after the passive reception filter. VRX equal to 500 mV AC to 1200 mV AC. Adjustment of gain. Maximum gain when jumper on 1 and 2, 15 and 16. A minimum gain when jumper on 7 and 8, 9 and 10. RT card. On front panel of this RT card, following are provided: measuring sockets, LED indications. This card consists the following circuits: delay circuit for TX bits photocoupler, EXOR gate, dynamic comparator, delay 1 circuit, 20 kHz oscillator, magnetostatic relay MSR, delay 2 circuit, final output for track relay. Code generator is sending code bits to modulator circuit in modem card, as well as it is sending code bits to comparator circuit in RT card after demodulation of received signals in modem card. These RX bits are sent to comparator circuit in RT card. The TX bit pattern and RX bit pattern are compared at EX or dynamic comparator, thereby generating 5 kHz signal which produces 1 second delay. The 5 kHz is converted into 20 kHz, which is going to magnetostatic relay. Magnetostatic relay MSR receives 2 vital inputs: RS signal with sufficient amplitude level directly received from RX card, bit comparison in the form of 20 kHz from comparator circuit. The magnetostatic relay is magnetic and gate. The output is high when both vital inputs are present. The output of magnetostatic relay goes to delay 2 circuit, thereby producing 1 second delay. The delay causes because of transmission and reception filters and transmission line which has characteristics that vary with length. The delay network provides a time delay between 10 and 14 milliseconds approximately. Test points and indications. Plus MSR and minus MSR greater than or is equal to 9.8 volt measured in volt DC. MSR voltage is depend on receiver voltage VRX. 20 kHz equal to 25 volt to 32 volt measured in volt DC. 20 kHz is present when TX bit and RX bit are matched. 24 volt local equal to 22 volt DC to 27 volt DC. Test points and LED indication on RT card. 1 ampere fuse on RX card. Out MSR equal to 4.7 volt to 7 volt measured in volt DC, track fee. Out MSR less than 4.2 volt DC, track occupied. Output equal to 20 volt to 28 volt. T measured in volt DC track free. Output is less than 0.6 volt DC track occupied. 5 volt DC is derived from 12 volt DC. The 5 volt rectifier circuit is mounted on RT card. 5 volt equal to 4.9 volt DC to 5.1 volt DC. 12 volt DC equal to plus or minus 11.8 volt DC to 12 volt DC. Ground is common for plus 5 volt, minus 12 volt, plus 12 volt supply. N normal system. R standby reserve system. Delay 1 first delay unit output. SW2 switch branch circuit 2 filtered signal. SW1 switch branch circuit 1 filtered signal. 24V.SW 24 volt auxiliary for the switch branch circuit. Modem card. Modem LFN 89709101-N and modem HFN 89709101-3P. There is no test point to measure the voltage on modem card. The card functions with point receiver RX card. This card is used when there are more than one receiving ends. This card consists separate demodulator circuit for switch 1 and switch 2, P1 and P2 jumpers. Keep them in 2 and 3 for single point TC. Keep them in 1 and 2 for 2-point TC. Ensure the following jumper position: P106 and P306 in position 2 and 3 for DTC 921. P105 and P305 are open for DTC 921. The regulations related to the receivers of switch branches are: for DTC 24, P2 and P4 jumpers on the RX board. For DTC 921, SW1 to SW8 switches on the RX board. Regulation of SW1 and SW2. After adjustment of main RX point receiver voltages to be adjusted as below. Keep multimeter probe on SW1 and SW2 of RT card and measure the voltages and the free threshold voltage level required at SW1 and SW2 would be 4.2 volt to 5.5 volt. This could be regulated by selecting dip switches mounted on receiver card. The switch receiver gain will be maximum when position 6 is selected on and minimum when position 1 is selected on. Only one dip switch among 1 and 6 should be selected. Do not keep more than one switch in on position. By default, dip switch 6 will be kept on, maximum gain from factory. Motherboard CN2 equal to transmitter receive cable connection, CN3 equal to switch receivers, CN5 vital output, CN8 for center feed TC. Power supply unit. Input 110 volt AC or 230 volt AC, 50 or 60 Hz. Output 10 volt DC or 50 volt DC to transmitter card plus 24 DIG plus 24 LOC plus 19 volt DC. One power switch is also provided for on and off AFTC. Two fuses are provided for 10 volt or 50 volt. This selection is given for high mode and low mode power. Track detection relay is plug-in type Q series 24 volt DC rated. Normally 6F/6B is used. R1 and R2 are connected to CN5 on motherboard. Tuning unit. Maintenance-free tuning units containing passive components are installed in location box alongside of the track. The capacitors C1 plus C2 and C3 plus C4 carry out the following functions. Create a parallel resonance with half of the joint S bond making up the inductance. The impedance is relatively constant inside the channel band and whose angle is 0 at the center of the band. Resistance load. Furthermore, the impedance on this load is notably higher than the simple inductive reactance on the coil. This enables transmitter to supply only the power necessary for the track circuit without reactive power overload, which would be absorbed by the coil reactance. Power factor improvement function. The inductance values LT1 and LT2 are in series with S-bond for calibration inductance values. Their value is varied so that the parallel resonance frequency between the coil made up of half the joint and the capacitors C1 plus, C2, C3 plus, C4 is as close as possible to the channel carrying frequency. The lack of joint calibration causes greater signal attenuation to the receiver and increased amplitude modulation on top of frequency modulation. The function of circuit L2, C71, C76, T4, C8, R61, R62, R71, R72, L1, C51, C56, T3, C6, R41, R42, R51, R52 is to eliminate the so-called pre-shunt phenomenon. The R3 and R4 resistance lower the joint Q factor. This is necessary because the high track input impedance in uncompensated track circuits cause excessive joint selectivity. The R1-R2 resistance limits the low-frequency current originating from the TE return. The current is closed using a transformer T1 even under equilibrium conditions between the rails. The transformer T1-T2 could become saturated if this current is not low. The LP1, LP2 is a cable pupin coil inductance. The tuning box is connected to the equipment, transmitter and receiver using a quad cable. Cable capacity makes its characteristic impedance totally reactive. The cable has a pupin coil inductance to limit these problems. The characteristic impedance of the cable with the pupin coil is mainly resistive. For closer length cable, the impedance can be well matched simply by using the transformer T1, T2. Types of TU, only DTC24. Types of TU, DTC24 and DTC921. Types of TU, DTC921 and DTC921. Balancing of traction return current in tune zone bonds are provided. In the rails, signals are sent and received by bonds. S bond is used where both side ALSTOM AFTC are installed. Alpha bond is used where one side ALSTOM AFTC and another side conventional track circuit are installed. Shunt bond is used where one side ALSTOM AFTC installed and another side non-tracked circuit area. The adopted solution makes use of an S-bond electrical joint which offers a high-level directionality, ratio between useful voltage and lost voltage, and allows a correct bidirectional transmission of the wide frequency channels. Installation: indoor equipments. It can be installed in AFTC room or in location box at site. Preferably it is installed in AFTC room so that system gets centralized. AFTC modules are inserted in Subrack in their proper slots provided inside the Subrack. These Subracks are connected to open cubicle rack. One open rack can contain maximum 6 or 8 or 10 track circuits. Separate arrangement is provided for track detection relay. Transmitter, receiver and power supply shall be mounted in standard relay rack in manner to allow maintenance and testing staff to view the track relay while making adjustments. Rear view of cubicle rack. Outdoor equipments. Tuning unit. Tuning unit is installed near to rail. Position the tuning unit mounting stand 1.6 to 1.75 meter from the inner rail, and it should be placed 600 mm from the ground level to ensure that it does not infringe the schedule of dimension. TU connections: CN3 always to lower frequency, CN4 always to higher frequency, A always to lower frequency, B always to center of bond, C always to higher frequency. Earth connection in tuning unit shall be done as per OEM manual. The connection to the electric joint is done by 3 insulated unipolar conductors of diameter 25 mm square with a length ranging between 1 to 5 meter. 2 of these conductors connect the tuning unit to the rails. The third one connects the tuning box to the center of the S-bond. The conductors are kept together by plastic clamps and are protected by a rugged plastic protection sheath. The procedure adopted is briefed below. Drill a hole on the rail 19 mm plus or minus 0.05 mm. Check the hole size with go or no-go gauge and ensure correct dimension of hole. If hole size is okay, place the bush made out of copper alloy in the hole. Place the drive pin inside the hole of copper bush. Position and tighten the drive pin with the chuck of special hydraulic tool. Drive out the expansion pin through the copper bush by special hydraulic tool by which the copper bush gets riveted on the rail. Check and confirm correct shape of copper bush. Use stainless steel M12 square head bolt, spring washer, plain washer and heli-lock nut to connect electric joint cable with rail. In addition to 1 lock nut are provided for extra safety. Laying of bonds. Note, all bonds must be prepared with 2 cables of same cross section, 185 mm square. Hot dipped galvanized steel cable to IS 2266 37 x 19 x 0.51 with 2.5 mm thick PVC sheathing. Drawing number 941120005. The distances L1 and L2 are measured from the edge of the sleeper chosen for the installation of the center of the joint. The fixing hole must be drilled about 10 cm away from these distances at the part of the rail not occupied by the fish plate fixing the rail to the sleeper. The return current to the next track circuit is passed through connection in between terminal bond center and impedance bond. The return current to the next track circuit, any other AFTC, is passed through connection in between terminal bond center and other AFTC alpha bond center. The return current to the substation is passed through connection from center tap of impedance bond connected at center of track circuit. Power wiring. As a standard practice, 6 square mm multi-strand cable being used for power wiring from AT supply and programmable selector switch to CVT. AFTC switching relay to TPR wiring. As a standard practice, contacts of switching relay QS3 1000 ohm 24 volt DC are being terminated on 96-way tag block. Quad cable size of 0.9 square mm or 1 square mm 24 into 0.2 multi-stand cable is permitted. Transmitter and receiver cable 1+1 pair of cable, quad cable size of 0.9 mm or 1 square mm 24 into 0.2 multi-stand brought from lightning discharger should be terminated to cable termination rack for easy accessibility to measure and record the TX and RX voltages. Cable termination. Outdoor cables for feed in and feed out. quad cable 0.9 mm diameter, maximum feeding 3 km maximum. Number of conductors, single pair conductor up to 1 km for TX and RX, double pair conductor above 1 km for TX and RX. Preparation of cable core chart. Separate quad cable should be used for transmitter and receiver irrespective of main and tail cable. Within a single quad, individual circuits use opposite conductors, that is 1 and 1 form one circuit and 2 and 2 form one circuit. Armor of each quad cable to be earthed at location boxes and at the tuning unit. Testing of cable. Minimum insulation resistance between each pair at CT rack should be more than 10 mega ohm per kilometer and should be recorded and maintained. Loop resistance of each pair should be recorded and maintained separately. It shall be maximum resistance of 56 ohm per kilometer at 20 degrees Celsius. Maintenance. Fail-safe adjustments. Filter in transmitter card is second order filter constructed with passive component for fail-safe requirement. It is designed with second order filters having property of flat stop band. The filtered signals are coupled through adaptive isolation transformer. In receiver card. The 4-stage band pass filter is designed with fourth order with passive components for fail-safe requirements whose bandwidth is narrow. The property of fourth order filter is flat pass band and flat stop band. The RX circuit is isolated at input side and output side to prevent external noise interference with the system. Preventive maintenance. Visual check whether the electric joints are in good condition. Clips fixing cables to the rails, connection to the rail and to the tuning units. Check the various voltages as indicated in the maintenance table in consideration of the climatic conditions and particular ballast condition. Then compare the values found with the values resulting at the time of putting into operation. In case of significant differences which cannot be justified by different climatic conditions, and in particular if external values are found to be at the limit, there might be a failure and the causes needs to be investigated. Tsr test. Check whether a non-inductive 0.5 ohm resistance interposed in any position on the track circuit except for the zone of the electric joints results in occupancy of the track circuit. Check whether a non-inductive resistance of 0.2 ohm interposed inside the zone of the electric joint causes occupancy of at least one of the track circuits. Check whether a short circuit inserted at 1.5 to 2 meter distance from the electric joint causes occupancy of the successive track circuit. If the track circuit occupies, check whether the calibration of the track circuit is corrected and that there are no defective components in the tuning units. To carry out measurements, the necessary measuring equipment and related tools should be as per the prescribed tool list. Parameters. Parameters of digicode DTC24. Parameters of digicode DTC921. Do's and don'ts. Do's. After gain adjustment, TSR testing is mandatory. In modem card, code bit setting should be as per table given in manual. In modem card, frequency setting should be as per table given in manual. Check lightning discharge connection to TX cable and RX cable. Directionality test is mandatory. Joint directionality is expressed only for S-bond type by the ratio of the voltage measured at 1 meter from the joint inside the track circuit to the voltage lost measured at 1 meter outside the joint. Before making any measurement whatever, check track noise by turning off all the track circuits and measure any noise present and related frequency. Don'ts. Don't put jumpers in vertical position. Don't change jumpers in switch on position. Don't put both fuses in power supply unit on rear side. Don't replace any board with power switch in on position. Don't touch the semiconductors ICs of the board with bare fingers as they are static sensitive components.